In today's lesson, we're going to look at function operations. And so functions can be combined using operations like addition, subtraction, multiplication, and division. I'm going to go ahead and make a note here. Subtraction and division, recall, are not commutative. So order matters. Make sure you're paying attention when you're doing subtraction or division. So let's look at number 1. Given that f of x is x squared minus 11x plus 18 and g of x is x minus 2, find f of x plus g of x. Okay, and express the result as a polynomial in simplest form. This notation is very simple, but I'm going to go ahead and make another note here. So the notation could be written one of two ways. Obviously this way, f of x plus g of x, like we see in this problem, but it might also be written as f plus g of x. We're going to see that in number 2 with the subtraction problem. So just noting, you might see a mixture of the notation. I started out with this one for number 1 because it's so obvious. We're just adding f of x and g of x together. So let's do that. F of x was x squared minus 11x plus 18 plus g of x was x minus 2. This is adding polynomials. This is combining like terms. So we only have an x squared term. I'm going to go ahead and label my answer, f of x plus g of x equals the x squared. I would combine my x terms, negative 11x plus 1x would give me negative 10x. And then we had 18 minus 2 gives me plus 16. Final answer. So adding functions, function operations. Number 2, given that f of x is x squared minus 5x minus 50 and g of x is x plus 5, find f minus g of x. So just a different way to write that notation. So it could be f of x minus g of x, kind of like we saw in number 1, or this way, f minus g of x would mean the same thing. So we're just going to subtract f minus g. What did I say? Order matters. So make sure you write f first. X squared minus 5x minus 50 minus x minus 5. When we subtracted polynomials, we distributed that subtraction sign through so we don't mess up the operation when we combine like terms. So going ahead and distributing that now and getting a negative x plus 5. I'm just going to be combining like terms. So again, I'm going to go ahead and label for my final answer f minus g of x equals. Combining like terms, we only had one of the x squareds. Combining my x terms, negative 5x minus x gives me negative 6x. And then we had minus 50 or a negative 50 plus 5 gives me negative 45. Final answer there. That is our result, our polynomial when we subtract those two functions. Number 3, given f of x is x squared minus 9x plus 18 and g of x is x minus 3, find f of x times g of x. Okay, so again, notation could look like that. The other way it might be written is f times g of x. Okay, so we're going to be multiplying these together, express our result as a polynomial in simplest form. So f was x squared minus 9x plus 18 times g was x minus 3. Now, when you're multiplying a trinomial times a binomial, you just use distributive property. So let me take the x and I'm going to multiply it with each of these terms here. So x times x squared, let me write it out because I think we're going to need to combine like terms. X times x squared is x cubed. X times the negative 9x will give me negative 9x squared. 18 and x gives us 18x. Okay, and then you would do it again with the other term. We're going to do negative 3 times x squared, negative 3x squared. Negative 3 times negative 9x gives us positive 27x, and negative 3 times the 18 gives us negative 54. Final answer, f of x times g of x equals. Final answer, we just have the x cubed term, one of them. We've got negative 9x squared minus 3x squared gives me negative 12x squared. 18x plus 27x is 45x. And then just a negative 54. I'm going to uncircle that because it I don't want somebody to think that it was combining with those x squareds. So there's our final answer, multiplying f and g together, x cubed minus 12x squared plus 45x minus 54. Number 4, given f of x is x squared plus 14x plus 48 and g of x is x plus 6, find f divided by g of x. Okay, so just like all the others, they could have written it separately. Don't be surprised on Delta Math or on a benchmark if you see it written a different way, or like they have it written here, f divided by g of x means the same thing. So order matters. Let's see. This would be the same as f divided by g, right? So let's do f on top. We have x squared plus 14x plus 48 divided by x plus 6. Now you have two options you want to how you can divide. It's up to you. A lot of you, just because of our recent lessons, you might look at this and go, ooh, synthetic division, okay? So two options here. I'm going to label as 1 and 2. Maybe you want to do synthetic division. Just making a note there. The denominator or the divisor is x plus 6. In your box would go negative 6. And then list your coefficients. We have a 1, a 14, and a 48. Always bring down that first number, multiply it with the box. 14 plus a negative 6 gives us 8. 8 times negative 6 is negative 48, getting that 0 remainder there. Final answer is x plus 8 would be your result from this division. Final answer, okay? Other option that you have, number 2, is you could use factoring, just whichever you're more comfortable with. Factor that numerator. So the factors of 48 that add up to 14 is going to be 8 and 6. So I'm going to show that factorization here. Divided by, we had x plus 6. Okay, do you see how those x plus 6 factors are going to cancel out, and your remaining answer is the x plus 8 here as well. So how did they use notation? F divided by g of x. Final answer here is x plus 8. Second part of our lesson, a composite function is the result of applying the rule from one function, maybe f, to the rule of another function, maybe g. And that new rule is denoted as f with this open circle, g. That's the notation. It's read f of g. And so we're going to be using this concept here. F of g of x is equal to f of g of x. So you might prefer to look at one of those notations versus the other. They mean the same thing. So I'll show you here. Number 5, given the definition of f of x and g of x below, find the value of g of f of 6. Now we always want to do the innermost function first. So let me make a note here. Okay, so looking back at our problem, we had g f of 6. We're going to do the f part first. So I'm plugging in 6 into that f of x function, okay? So 6 squared minus 6 times 6, right? It's in two places. We've got 6 times 6 is 36, minus 6 times 6 is 36, plus 1. Final answer for this first part, those cancel out. We just have 1. Okay, so f of 6 was 1. What do we do now? We're going to take that 1 and plug it into g. So that's what that notation is telling us to do. G of f of 6. Do f of 6 and then plug it into g. So now I'm using that second function. We're doing g of 1 was from the first part. So 5 times 1 plus 15 gives us 5 plus 15, or final answer 20. G of f of 6, final answer was 20. We did the innermost part first. It said put a 6 into f, get your answer, and then put that answer into g. Let's try again. Number 6, given the definitions of f of x and g of x below, find the value of f of g of 2. Did you notice that the order is different here? And it does matter. Complete the innermost part first. So we're going to be doing g first this time, and we're plugging in a 2. So the g function is negative 5 x, we're plugging in the 2, plus 1. We have negative 10 plus 1, or final part for g of 2, negative 9. Now take the negative 9 and put it into f. We have negative 9 squared. Be careful here, right? All of negative 9 is going to be squared. 6 times negative 9 plus 11. So negative 9 squared is what? Positive 81. 6 times negative 9 is going to give us negative 54 plus 11. Simplifying all of that is going to give us 38 would be our final answer. The notation they used, f of g of 2 is equal to 38. Forgot one of my parentheses there. Last one, number 7, given the definition of f of x and g of x below, find the value of g of f of negative 7. This means the same thing, just written differently. So let me convert it. Maybe you have already locked in on that other notation. This would be the same as saying g of f of negative 7. Okay, same thing, just a different way to write it. I want to make sure you're familiar with both because I don't know how they'll present it on your benchmarks or on your EOC. So again, completing the innermost first. If you're using this other notation, just whichever is closest, okay? So f of negative 7 is going to be equal to negative 2, plugging in that negative 7 minus 13. Negative 2 times negative 7 gives us positive 14. Minus 13 is positive 1. So plug in the 1 now into g. 2 times 1 squared minus 6 times 1 minus 10. Let's simplify here. 1 squared is 1. 2 times 1 is 2. Then we have a negative 6 times 1 gives us negative 6 minus 10. We're going to have negative 14. So final answer using the original notation, g of f of negative 7 is equal to negative 14. Final answer. So that's function notations. Just be mindful when you're doing subtraction or division. Make sure you are doing it in the proper order. You did have 2 options there on the division, however you want to work it. Synthetic division should be just fine. Some of you might think the factoring is a little bit easier or faster, whichever. But we got the same answer, either method. And then composite functions, apply the function using that input in the innermost one first, and then put that answer into the next function and simplify. So not so bad. Practice, guys, and let me know if you have questions. I'll see you in class.